Hello and good morning, everyone. My name is Junaid, and today I'm going to talk about microservices, what it is, and why is it relevant. Before we proceed, I'll start with a little bit about myself. So my name is Junaid Akhtar. I work as AWS Cloud Engineer at a Cloud Devo Team Germany. I have more than 7 years of experience in IT industry with nearly 4 years of experience building cloud native solutions in AWS and Microsoft Azure. My main skills are AWS, microservices, DevOps, high performance computing, especially AWS EC2 F1 instances, which are the FPGA high performance computing instances in AWS, and also infrastructure as code in Terraform. I live in Düsseldorf, and I really love Formula One and skiing. Quantum computing is and also one area of interest that I really like to spend some time on it. Our agenda for today is we'll start with a brief history of microservices. Then we'll look at some traditional architecture, then microservices architecture. Then we'll compare some advantages and disadvantages of using microservices. And then we'll wind up with the summary and why do we need microservices. So a little bit about history. So microservices actually first appeared in May 2011 when some software architects actually gathered in a workshop nearby Venus, and they actually used a term microservice to describe a new software architectural pattern. Now, before I go deep dive into microservices and explain what they really are and how it actually works, I'll tell you a little story. And this is actually very classical story I used to tell everyone when I have to explain what microservices are. So there was once a person, and he decided to open a restaurant, and he said that okay, he will serve different types of food, but he will start with Chinese soup and sushi in the beginning. And the restaurant finally opened, and people started to come by, and they really liked the food, and they were actually very happy. Later on, time passed by, and the owner of the restaurant realized more customer potential, and he decided to add some new variety of food in the restaurant. And now the problem with this is the restaurant only had one kitchen. That means all the chefs who are cooking different type of food, they're actually using the same kitchen. Now, if you want to add a new type of food, then it means you have to install some additional equipment for new food in the kitchen. That means the kitchen won't be accessible to other chefs as well. That means the restaurant will be closed for a temporary period. And that really made some customers unhappy, and they actually started to go to different places to eat their food. But later on, after some temporary time, the restaurant was open again, and the customers started to come by again, and he attracted a lot of customers. At one point, the restaurant was running at 100% capacity. That means more people started to come by, and they actually had to wait in longer queues, and they were kind of disappointed and unhappy because they have to wait in order to get their food. Now, there was another, in order to sort the queue issue, the restaurant owner decided to open more restaurants nearby. So he actually divert people to open new restaurants so that they don't have to wait in a longer queues. And he actually did again and again, and eventually the people were happy. Now, there was another person in the same city, and he was also running the same business, but instead of doing multiple type of food in a single restaurant, he actually decided to rent out some food stalls in a food court. So I would say everybody is familiar about food court in a shopping mall. So instead of opening one restaurant with a very big kitchen, he decided to rent out some small food stalls. They would serve a very specific type of food, but not multiple type of food. So, for example, chicken, pizzas, donuts, and so on. And the good thing about this was that whenever he wanted to introduce a new type of food, instead of using a same food stall to install a new kitchen capabilities, he will just rent out a new food stall and he will just install the new capabilities. That means that he don't have to close the other food stalls at all, and the people would simply come by and eat their food normally as it is. And also, if any food stall receive too much capacity or so many people, he could just scale them out, adding some extra food stalls in the food court. And people were actually very happy, and you don't have to scale out the entire restaurant like we saw in the previous example. Now we look at the traditional architecture. Now this is actually very classical N-tier or 3-tier architecture, where we have a user interface layer where user can actually see data or send data for processing, and then we have a business logic layer. So this is where all the data sent or requested from the customers is actually processed. So business logic layer usually consists of multiple services or modules. So here we can see an example of very typical e-commerce application, where we have a customer's employees, customer can place order, and they can track actually shipments and other sort of stuff. And also this entire application have one single database where all the data is stored or fetched to show to the customers. And now the problem with this architecture is this business logic layer, it looks like multiple modules, but in the end it is just one monolith. That means it is just one single deployable file that you have to create, and it have some sort of single point of failure. So for example, all the modules are kind of dependent on each other. So for example, during runtime, if an error occurs in orders module, then means the entire application will be unavailable. Also, if you have to make minor changes in, let's say, in customer module, let's say you also want to display a middle name of the customer as well. Now what you have to do is you have to rebuild the entire application and also redeploy the entire application from scratch. That means for some amount of time during the deployment, the software will be unavailable, and that customer will actually start to notice. Now we look at the microservice architecture. So microservice architecture is actually very similar to what we saw in the food court example. So now instead of deploying all the services or modules in a single monolith file, each module is actually decoupled from other modules. So it has its own runtime, and it has its own code base, its own individual database. So here, every time if you want to add new capabilities to the entire application, you don't have to redeploy the entire application. So for example, if you want to add new capabilities to customer module, let's say middle name, that means you just make changes to the customer module or customer microservice and redeploy this one. That means the people will actually not notice a deployment or unavailability of the entire software application at all. Also, if you want to do some intercommunication between modules, then you can actually consider some communication mechanisms such as REST or messaging. And in order to get all the data from database, so client simply could use an API gateway, and API call is made to the relevant microservice, and the data is fetched and returned to the client. Now we look at some advantages and disadvantages of microservice architecture. So some advantages, some microservices are actually very loosely coupled, so they don't have a single point of failure. Unlike in monolithic architecture, they're very tightly coupled. That means they have sort of dependency on each other, and if one module or one service fails, the entire application fails. Also, microservices have increased agility. That means you can actually use a DevOps practices in order to deliver your workable product very quickly. While in monolithic architecture, it has some build and release lifecycle, and usually you have to comply with those lifecycle, and it is usually very slower in order to build and release the workable or the changes in the entire product. Also, microservices are actually technology independent. So you can actually use whatever tool or technology you want to build an individual microservice. For example, for customer service, you could use Java. For order service, you could use, let's say, C# and so on. And also, you don't have to comply with a single type of database for each service. So you could actually use a NoSQL database that works well for order services and all, maybe a graph database for customer services. So you're actually very independent on technology. But in monolithic architecture, actually, it is very difficult to adopt a new technology because if you want to write a new module and say you want to write in a C#, but your whole application is actually written in Java, then you actually have to rewrite the entire application in C#. So it is actually very difficult to adopt new technologies. Also, microservices have its own runtime, so you don't need to scale the entire application, but you can actually scale a single microservice independently, like we saw the scaling of food stalls in the food court. But monolithic architecture, it is actually very difficult to determine which module is receiving more traffic and at what point we can scale it better. Some disadvantages. So microservice actually create a different type of complexity. That means you have to be very knowledgeable about some distributed environment. So you have to consider the network latency, communication, and so many things. While monolithic architecture, it is just one single deployable file, one single application. So simply write code, develop, build, and deploy easily. And you don't have to worry about intercommunication between other services because they have sort of type dependency. Also, microservices are difficult to manage since microservices have its own runtime, and as soon as the application size increases, that means more microservices, then you have to manage entire application, and it is actually very difficult to manage multiple or more number of microservices. While monolithic architecture is usually have a 3-tier architecture, so you just have to manage 3 files. Also, global testing is very difficult. So when you write microservice, that means you have to write an individual test for each microservice, but you can't write a global test for all microservices because you have to be very knowledgeable about distributed environment, and usually it is very difficult to do that. And also debugging is another challenge since the logging of each microservice is stored inside in individual microservice, while in monolithic architecture, the logging is actually stored inside just one single application. So it's easy to debug, and it's also more suitable for small projects where you have, let's say, few thousands of lines of code. Also, you have to consider some higher upfront costs for a microservice. So you need larger infrastructure since each microservice has its own runtime. That means it's need more memory, more compute power. While monolithic architecture, it has only one single runtime. So you could use a small hardware instances, and you can actually scale them horizontally very easily. So summary, so why use microservices? Microservice has increased resilience. That means it does not have any single point of failure, unlike we saw in monolithic architecture. It is also easier scalable because each microservice has its own independent runtime, so you can scale each microservice independent of other microservices individually. Also, you can use a suitable programming language and database and tools, whatever you want, for a specific microservice, and you don't have to comply with a strict requirement of any tools and technologies. Also, microservices, it is very easy to it is actually very faster to market them, because you have to write one microservice and you don't need to rewrite the entire code base, or in order to modify a feature, you simply have to just rebuild and redeploy a microservice. That means the other entire software application won't be affected, and you can actually make and deliver your changes easily. And also microservices complies with DevOps practices. That means you can use the continuous delivery model easily. So that's all for today. I hope you like my talk, and thank you very much for your time.